Okay, second factor is changes in pressure. So for the second factor, the pressure is only for the system with gaseous component, since liquid and solid are incompressible, cannot be compressed. Right, so the pressure only change the position of the equilibrium, but not the value of K. So there are three ways to change the pressure. So first, by changing the concentration of gaseous component. Okay, right. So next, changing the volume of the reaction vessel and adding inert gas either at constant volume or at constant pressure. Okay, alright, so we take a look at this example. So let's say I have 1 mole of PCl3 gas react with 1 mole of Cl2 gas, it will produce 1 mole of PCl5 gas. So if the disturbance here increase the total pressure, okay, alright, so by decrease the volume. So we relate this with the ideal gas equation, PT equals to N total RT over volume. Alright, so when total pressure increase by decreasing the volume, okay, so it will affect the value of QC is not equals to KC, and the system is not at equilibrium. So the system try to achieve back new equilibrium by reduce, okay, the pressure of the gas molecule. Right, so in order to reduce the pressure, right, so the system should proceed or should shift direction to the side that has less number of mole. Okay, less number of mole. So hence net reaction proceeding to the less number of mole. So therefore, the system will shift to the right. Okay, why to the right? We refer back to the equation. So we can refer here. So at the right-hand side, there are 2 mole of gases, whereas at the product side, only 1 mole. So therefore, the equilibrium will shift to the side that has less number of mole. So it will shift to the right. What happened next? So the concentration of both reactant here, it will decrease. Okay, as for the concentration of the product PCl5, it will increase. Alright, next. Okay, same example, but this time decrease the total pressure by increase the volume. Okay, so we know that P total equals to N total RT over volume. So if we decrease the total pressure, actually by increase the volume. Okay, so as the effect, the value of QC is not equals to KC. This means that the system is not equilibrium. System try to achieve back the new equilibrium by reduce the disturbance. How to reduce? So because the total pressure is lower, so it will increase the pressure. So P total equals to N total RT over volume. Okay, so meaning that we want to increase the pressure, but how? So direction should shift to the side that has greater number of mole. Okay, so therefore the net reaction proceed to more number of gas, which means the equilibrium shift to the left side. We are referring to the equation, so we can clearly see that at the left side, the number of reactant is bigger than the total mole of at the PCl5. Okay, which means at the reactant side, there are 2 mole of gases that is greater than at the product side, which only have 1 mole of gas. What would happen next? So therefore, the concentration of PCl3, the products, and Cl2 will increase, as for the concentration of the reactant will decrease. Okay. Alright, next. Okay, so remember, so when the volume decrease, okay, so the total pressure will increase. and vice versa. Okay, volume increase, total pressure decrease. Okay, alright. So keep in mind. Alright. So this is as the conclusion. So we take a look at increased pressure. So we increase the pressure. Okay, which mean the volume will decrease. Okay, volume will decrease. Right. So the system try to reduce the pressure of the gas. Okay, reduce the pressure of the gas by shift to the side that has less number of moles. So therefore, it will shift to the fewest mole. Okay, fewest mole mean less mole of gas. Okay, right. So next, what would happen if decrease the pressure. Okay, so decrease the pressure, which mean, decrease the pressure here, which mean we increase the volume. So the system try to increase the total pressure by shift to the side that has greater number of mole, or most number of mole. Most here mean greater. Most here means greater. Okay, next, what would happen if the volume, we change the volume. We change the volume. Okay, changes in the volume, what happens? So no shift of equilibrium. So if both sides have the same number of gas mole. Okay, right. So we take a look at the example exercise. Okay, consider the following equilibrium system. Right, so we take a look at A. Okay, this question here is predict the direction or the net direction in each cases as a result of the increasing pressure. Increasing pressure. So we write the ideal gas equation P total and total RT. Okay, so when pressure increase, and total RT. So pressure increase, volume will decrease. Okay, now the system try to reduce the pressure. So target here to reduce the pressure by shift to the side that has less number of mole. Okay, less number of mole. Okay, so we take a look at question A here. Alright, so solid we not consider for the solid here. So we have 3 mole at the right hand side. Product side, solid also not consider. So we have 2 mole. 2 mole gas. Return 3 mole gas. Alright. Okay, so the system will shift to the less number of mole, shift to the right. Okay, shift to the right here. Okay, as for B, look at question B here. Alright, so for right hand side, we have 1 mole. Okay, product side, 1 plus 1 equals to 2 moles. Okay, therefore the system will shift to the right hand side, left. Okay, shift to the left. Okay, next, C. So gas, so 1 mole plus 1 mole, we get 2 mole. Okay, for the product side, 1 mole and 1 mole. So also 2 mole. Okay, so therefore for this one, there is no change in the equilibrium direction. Why? Because mole of reactant, total mole of reactant and total mole of product is the same. Okay, and the D here, so we have 2 mole at the reactant side. Product side, we have 3 mole. Alright, so the system will shift to the right. Shift to the left. Shift to the left side. Okay, so this exercise. Okay, now predict the effect of increasing the container volume. So meaning that volume increase on the amount of each reactant and products. Okay, amount So amount here in terms of, okay, more or less product form. Okay. Alright, so now we take a look. So P total, okay, we know that P total equals to N total RT over volume. So increase the volume. So what will happen when volume increase? So the pressure will decrease. System try to increase the pressure. Okay, so therefore, okay, increase the pressure. So the system will shift to the side that has greater number of mole. Okay, greater number of mole. Okay, now we take a look here. So for A, 1 mole of the reactant side, product side 2 mole. 1 mole, 2 moles. So therefore, it will move to the shift to the right side. Okay, shift to the right side. So what would happen? More F gas and it will form less F2 gas. Okay. Right, next B. So there are 2 mole at the reactant side and we have 1 plus 3 equals to 4 moles. So it will shift to the right. Okay, also shift to the right. So therefore, more C2H2 and H2 gas less CH4 gas. Alright, so for C, liquid is not considered. Okay, so product we have 1 mole. So therefore, it will shift to the right. Okay, so therefore, less CH3OH and more CH3OH. Okay, this one is in liquid, this one is in gas. Okay, next, D. So we have 1 mole, total 2 mole. Okay, at the product side, 1 plus 3 equal to 4. So it will shift to the right. So when shift to the right, what will happen? So it will form less CH4 and NH3, more HCN, and more H2. Okay.